Hey everyone. So I'm not sure how to put this, but I kind of forgot to connect the charger and my battery is a bit low. I don't know how long I can go. I mean, would I make it till the end? I I'll try my best to make it till the end. I'm not on Chrome, I'm on Firefox. And I was just kidding. I mean, this is this is about power management and measurement. So obviously I connected the charger, but this presentation talks about the basic premise is what is happening when your battery is draining and how do you understand what is happening. That was the whole idea. So I'm sorry for the poor joke if it was, but I thought it was a cool way to get started with the topic. So I guess I'll just start. Okay. All right. So here's, I hope I'm on time. Maybe it's 5 seconds earlier now. All right. So here's a very brief introduction. I'm just going to skip over it. So I was a Google Summer of Code 2018 student with GNOME, and I worked on implementing the Power Panel in gnome-usage. It was a really exciting topic. It was a really exciting project, and I was mentored by Felipe Borges and Christian Kellner. Great people. I really learned a lot from them. Thank you so much for the wonderful experience. So this presentation is about the project that I did, the findings, and what I plan to do ahead. All right, so I'm going to give a quick overview. First, we try to understand what is the problem statement. I'm going to turn on the webcam if that's fine. Can you see me? All right. Yeah, can you guys see me? Okay, great. Thank you so much. Christian, I learned so much from you. Thank you so much for everything that you taught me. All right, let's go. So the first one that I'm going to talk about is what is the problem statement? What are we dealing with here? And second is that once we realize what we are dealing with here, I try to dig into what our competitors, I mean, not competitors, but what our peers are doing. So what is Windows doing? What is Mac doing? What is Android doing in terms of and how do we and then finally we talk about the system architecture, what I want to build and what I think would make an impact in all of our lives. Finally, we talk a bit about gnome-usage, which is the application where I work at. Brainstorming is for all your queries. So let's go. All right. So I think all of us have faced these kind of situations that I've been barely using my system for 30 minutes and the battery is already at 50%, or maybe why are the fans running at full speed? I'm just using Chrome. I'm just using Firefox. I'm just checking my mail. Why is the fan blasting at full speed? I have no clue what's happening in my system, right? And this one is even more perplexing, I would say. I just charged my laptop full last night, and today morning when I opened it up, it's 87%. Sometimes it's even dead when the battery is like 15% at night. So this is really interesting to understand what is happening. Why is my laptop not sleeping when it should be sleeping, right? So I like to understand this as the fact that why is a process consuming much more energy than the amount of value that I'm deriving from it? Why is a process running on my system that is taking up so much energy cost as much as I'm not even putting into it, right? That should not happen. And this project aims to solve this problem. All right, so let's say that if you had this kind of an application which told you, hey, your screen consumed like 90% of your power and your Inkscape work consumed like 4% of your power, wouldn't that be absolutely great? You could finally make sense of what all these numbers actually mean. I mean, you could understand where is this 50% and 87% actually coming from, right? So this is the mock-up for gnome-usage, and credits go to Alan. Thank you so much once again for the mock-up and for your help. All right, so these were the end user use cases. Now, what about developers? How do these statistics help GNOME community and GNOME developers? Why am I, as an application, getting so many bug reports about killing the battery? I mean, what is it? I mean, is there a memory leak? Is it a infinite for loop? What is happening in my application? And how do I quantify the power impact of my code? Now, this is a big question. As a developer, I don't think in terms of power. I think in terms of runtime, I think in terms of memory, but I don't think in terms of what is the power impact. So how can I quantify that? How can I actually put a number to the amount of energy that my application is going to consume? So this data will give developers the ability to see how and where actual battery power is being consumed, right? And let's take an example of games. All of us love to play games. So a game should not ideally be doing a lot of memory accesses. It's a CPU heavy application. And if your game is running really slow, um, our objective is to help you understand that, okay, your game is being bottlenecked by your RAM and it's not being bottlenecked by your CPU or by your GPU. So that is one of the use cases for this kind of data. And this data can also allow system administrators better control, better management, everything. Talking about system administrators, let's take a look at how this data can be useful for our friends in enterprise systems. So how can this data be useful for enterprise folks? Whenever we talk about cloud vendors, for example, Red Hat, and IBM and everyone else, cloud is data center, and data center means the total cost of ownership. So I got these numbers which basically say that the energy cost of running your servers is a 55% of your total cost of ownership. By the way, this total cost of ownership is somewhere in billions. It's easily billions. So you are spending almost 500 million on just running your servers. That is a huge amount of money, right? And then you're also spending so much energy, which is burning so many fossil fuels and everything. So how about we actually understand where this energy is going? Power attribution. Attribution means this. So this is what we refer to as power attribution. Attribution means breaking down the power consumption by the devices and the applications which are actually using that power. That is what I refer to as attribution. So power attribution can enable data centers to monitor high energy cost applications, and it can help improve the scheduling across your cluster. So now you can actually schedule applications which need high amounts of power for high performance clusters, right? So then you end up spending your energy budgets much more wisely, and that way you can even save on your carbon footprints, right? That can be a really great tool. Enterprise administrators can do all sorts of wonderful things with this data. So I believe that this data is really useful for everyone involved in our community. All right, so that is a problem, but why is this problem there in the first place? What is the source for this problem? The source for all power problems is the battery. Your battery is a finite resource, right? At the beginning of the presentation, I was like, I don't have battery, and now I do. So your battery is the source of all your power. And unfortunately, Moore's law doesn't apply to batteries. Software engineers have always depended on Moore's law for the huge power gains, for huge performance gains, but Moore's law has not applied to batteries, unfortunately. This is the reason why your smartphone batteries have not grown in capacity at all. You buy a smartphone 5 years ago, you still get 3,000 milliampere hours. You buy a smartphone today, you still get 3,000 milliampere hours. So does that even make sense? Your battery is not even growing, but your screen size has grown from 4 inches to 5.5 inches. So you're spending more and more energy with the same amount of budget. And this budget is known as the power envelope. Power envelope is a system, it's an industry term, which basically states that your device is supposed to operate within some particular budget. Let's say that it's 45 watts. So let's take this example of as a tank, as a reservoir, which has some fuel in it. So power budget can be understood as the capacity of this tank and the ability of this tank to deliver this fuel to your device. Okay, so this is the power envelope. And today, if you go to any industry which has consumer-facing systems, mobile devices, laptops, tablets, anything, power envelopes are your #1 design constraint. That is a proven fact. All fancy technologies that you guys want, VR, AR, everything is constrained by power. And solving this problem can actually enable us to develop much more functionally widespread devices. Okay, so how does power attribution help solve this issue? I mean, okay, you can do everything with power, but how can power attribution fix these problems? Well, I would say this is a bit of cliche, but obviously you cannot improve what you cannot measure. Please don't kill me for this. It's a management cliche, I know, but it works beautifully for this concept. As developers, we need to understand where our power budgets are being allocated and where they are going, right? So if we're not aware of something, how can we fix this? How do we even know what to fix? So despite immediate user impact in all industries, be it our end users, be it our developers, be it our enterprise customers, power attribution systems and infrastructure is really, really undeveloped. And it's hard to understand why is the system was not developed in the first place. I keep wondering. I have been thinking about this question for the past 2 years, and then I decided, okay, let's bother these guys also with this question and get their thoughts on this. So one more thing, I would say this is not a good comparison point, but this only serves to say that our peers have understood the importance of this feature. They have understood the importance of power for all modern device development, and they have attempted to close the gap. Linux solution is still awaited. So, I mean, this is a big challenge in front of us. All right, so what is the challenge that we're facing? How do we fix this? How do we actually get this done? So again, one more cliche, hardware is hard, but why hard? Why is this problem hard? So we know that processors run at 3 gigahertz plus. That means a processor does billions of operations each second, right? Whereas humans run on like hertz plus minus, I don't know. Some guys run at 10 hertz, some guys run at 1 hertz. Basically, they do one operation in 1 second. And I recommend you guys drink a bit of coffee presentation so I can increase your processing speed from 1 hertz to maybe 10 hertz or something. Please forgive me for these poor jokes. I'm your guy. These terms. So humans run at hertz. So the example serves to illustrate the fact that it's very hard to get numbers from a system which is performing 1 billion operations a second and interpret them for a human which is running at 1 hertz operation per second. Does that even make sense? How can you compare these two guys? They are at time frames is quite hard. It's really size is what makes it inaccurate. This was the first challenge. The second challenge is that power is a hardware concept. As a developer, as I said, when you write code, when you write a loop, you don't think that, oh, guy is going to take watts of power. I should reduce the power. No. Think this guy is running OR and is going to take off enough memory, right? So how do I reduce the time? So power is always considered as a hardware concept, and devices are used by software simultaneously. For example, your game using your CPU, it's using your GPU, it's using your display, it's using your memory in low. So how do you quantify this power is distributed across so many components? And the challenge is, even if you want to quantify, let's say that you have a game which is using 20 watts of power, your GPU is using 20 watts of power, display is using 50 milliwatts of power. You with 50 milliwatts of consumption, right? That can be one way to calculate. Here comes the best part. Hardware chips do not expose this information. There's no way to understand that this guy is using 10, this is using 20. Manufacturers do not give out this information. So if you have the information in the first place, how are you going to calculate it, right? So we see this is such an important requirement. Manufacturers are not on board with this requirement because of high costs. The only reliable measurement values are for processor wattage, which means your CPU power, and that is only for post-Nehalem microarchitectures. Fancy term for saying microprocessors made by Intel after 2012. Only systems made by Intel after 2012 expose this value to the user. Before that, they decide. And we have the available backcard CPU. So we don't even have the numbers to work in the first place, right? Okay, so we see that we don't have. Let's try to still go deeper into the problem and see what numbers do we actually need? Hey, can you hear me? Oh my God, thank God. I'm really sorry for this. Thank you so much for waiting on me. I don't know how long I can go on it, but I'll try to quickly speed through it. Please let me know whenever I should stop. I don't know, I had to restart my router and now it's working fine. I'm just waiting for presenter privileges, and as soon as we have that, I'll quickly go through. I'll try to skip the case studies for now and try to understand what's the solution to this problem. I'm sorry for all this issue. I checked all these beforehand, but I guess it's Murphy's Law. Whenever something has got to go wrong, it will go wrong.
Also, you're almost out of time.
Yeah, I understand. It's like 15 seconds now. I don't know. What do you guys say? Should I continue or should I drop it right now?
You can continue for a couple minutes, 2-3 minutes, and we start the questions.
Thank you. Thank you so much. Christy, if you're, I got the privileges. Thank you so much once again. All right, so I'm going to skip this. So basically, these are the hardware devices which actually need these kind of computations in the first place, okay? And I think one interesting tidbit that I would like to cover here is that till 2016, Apple could only release MacBooks which supported a maximum of 16 gigabytes of RAM. Can you believe it? Why was this so? This was so because they were unable to power more RAM than 16 gigabytes. That was due to the DDR3 power requirements. And that is really, I mean, it's really amazing to see that even as such a big company, they could not solve this issue. So this is a serious concern which is facing all manufacturers and programmers. And it's best that we solve it really well. All right, so given all these challenges, how do we solve it? The ideal solution, I mean, as a logical solution, we would think that you should determine the time spent on the CPU, the input output, the memory. Okay, so if you say you're spending 10 milliseconds on the CPU and 20 milliseconds on the I/O and 30 milliseconds on the memory, you multiply it by the power for these components, right? So you multiply CPU 10 milliseconds by 10 milliwatts gives you 100 millijoules, right? So that can be understood as the power for these components, right? Now, what is the why it's not as simple as it sounds? First of all, how do you compute the time that is spent? Processes need to actually calculate how much time they are spending in each component during each context switch. So the process is required to do an accounting update for each task switch along with all the other housekeeping. This infrastructure, I'm not exactly sure if this infrastructure is already present in processing accounting infrastructure in Linux, but that is needed to enable this solution to work. Now comes the second and tricky part. All right, so we got the time. Now, how do we obtain the power, right? Heisenberg's principle, if you measure the velocity, you change the position. If you measure the position, you change the velocity. So if you measure the power of your CPU, you change the power of your CPU. For example, let's say that you are asking your CPU, hey, what's the power that you're running at right now? Your CPU says a CPU was actually sleeping in the first place. It was consuming like 1 watt. And now to answer your question, it has to wake up. And it wakes up and says, hey, I'm using 10 watts right now. So this is skewing your measurement completely, right? I mean, you don't get the right number in the first place. The right way to get this is using an observer probe, using a current and a voltage probe, and actually getting that value in an oscilloscope. But we can't expect our users to have oscilloscopes dragging around with their systems, right? And another more problem is that How do you obtain these? How do you obtain these power values? You can obtain these power values via ACPI. You can obtain these power values via data sheets. But these data sheets are so conflicting, right? One data sheet specifies one IC's power consumption as 10 watts. Another one says 12 watts. And it's the same IC, just from a different manufacturer, right? It's supposed to do the exact same thing. And even then, there is so much difference. And we don't know how to resolve this. How do we align these much differences and make a sense of this, right? This is a big challenge in this problem. So our friends, which we saw earlier, have managed to solve this problem. What they do is that they collect all this data from the devices running, from their devices. Okay, so all right, this is the case studies, which basically tells how Microsoft, Apple, Android are solving this problem. I'm going to skip this part in the favor of finishing this up. I'm really sorry for you guys can download the presentation and please mail me for any questions. Okay, so Windows runs something known as the energy estimation engine, which is mining all the data on your device for building its power models. That is the short and sweet version of what is written here. Microsoft has stated that 85% accuracy can be achieved for these power values using these software models. And extremely few PCs in the market have dedicated chips to obtain these power values in the first place. Okay, so that's Microsoft's solution. This is how they present it to the user. The most interesting part here is Microsoft does not tell you how much your CPU or your memory or your I/O is consuming. Microsoft just tells you, hey, your mail is consuming 9%. Cortana is taking up 6%. So they don't consider the hardware parts. That was one part. The second one is the task manager. If you have seen the recent task manager, it is showing you these power usage trends.
Excuse me, but you're out of time. Please look at the question, try to answer the questions, and we can go to the next speaker, please.
All right, sure. Yeah, all right. Thank you very much for the remark. Okay, so this is what the Windows is doing, and I'm going to skip to the questions now. The backend, how they are actually getting these values, and this is what Mac OS is doing. Here's a bit of detail. Here's what Android is doing, and Android is getting it for hardware and software both. And what I wanted to do, what is GNOME's power measurement system architecture? And we need data collection, and we need to develop power models, basically Gaussian distributions, and we need to incorporate these models in a regression model. And this can also be understood as a multi-arm bandit problem. All right, so do you guys agree? Would you guys be willing to give your data? I don't know. And finally, I would like to present all of this in this format. And before ending, I would like to give a shout out to Felipe Borges and Christian Kellner for really teaching me a lot and for encouraging me for this project. It's a beautiful project. It's a difficult project. And I would like to thank them for their support so far and actually do this in the first place. And any questions, please share them. I would love to get some questions, and you can always mail me. Thank you very much for the feedback. It's really great to see everyone here and the encouragement, and that is why I love this community so much. That is what has stuck me with GNOME so far, and it's absolutely amazing to see you all once again. I really hope to meet all of you once again next year. Thank you very much. I'm going to give over the
questions that are in an Etherpad. See in the public notes at the left.
Yeah, I can see the questions, but the one question that I really like is that plugging a dongle like the WhatsApp between the machine and the wall socket. Okay, so what you are doing here is that you are measuring the total system power using this WhatsApp dongle. And the total system power is basically everything combined in one go. Your CPU, your GPU, your memory, everything as one go. You don't even know where exactly the power is going. We want a breakdown of how much each process is consuming, how much the CPU is consuming. Why is my system waking up at night to check my mail when I wanted to sleep for my really important presentation next day, right? So I don't obtain those kind of statistics using the WhatsApp monitor. And that is why we need this kind of attribution mechanism in the system itself. Another question that I can see is Free Desktop is working on a daemon to manage applications in the background. Unfortunately, I'm not aware of the daemon, but I would love to look into its development. I would love to be a part of it. Thank you so much. Thank you so much for bearing with me. I'm really sorry for this issue. And I, I hope to present this once again. Thank you so much once again. Good.